Okay, composite functions. If you have f(g) of x, you always start with the letter closest to x. So we're going to start with doing g first and then do f of that. G takes whatever you put in and cubes it. F takes whatever you put in and lns it. So if we start with x and do g first, you're going to get x cubed, and then f is going to ln that. So what we end up with is gx first, we get x cubed, and then f of that is going to be ln x cubed. So that's fg of x. If we also apply our log rules, we know that ln of a to the b is b ln a. So ln of x cubed is the same as 3 ln x. So that's solved the first part. It then says state the transformation which wraps the curve y equals f of x onto the curve y equals fg of x. Well, people probably find the language here quite confusing. If f of x is ln x, and if g of x is 3 ln x, then what have you done to ln x to get 3 ln x? Well, clearly you've multiplied it by 3. Now you should know that when you multiply a function by 3, what you're doing is you're multiplying the outputs by 3. So if you have a graph and it looks like this or whatever, and you triple all the outputs, you're basically making them 3 times as big. So the output that was here is now going to be 3 times up here. The output that was here is going to be 3 times higher over here. The output that was here is going to be 3 times higher over here. So you can see that you're stretching it, and it's obvious when it goes over the x-axis, going like that. Below the x-axis, if the output used to be -1, it's now going to be -3. If the output used to be -10, it's now going to be -30. So the whole thing is being stretched away from the x-axis factor 3. So that's our transformation for part 2. The first answer is 3 ln x. The second answer is that it's a stretch scale factor 3. And then, is it parallel to the y-axis or the x-axis? Well, it's moving in the y direction. It's a stretch in the y direction. So that means it's parallel to the y-axis. That's the question solved.